Hey guys, welcome back. This is lesson 119, page 595 in your books. And you'll see here I've got the chart and the function written from the top of the page. Now, last lesson I introduced the terms independent variable and dependent variable, and that's actually gone over in this lesson. And so we'll just look at that again pretty closely. So what we see here is the function y equals 8x plus 2. We talked about that variable that is by itself is the dependent variable. It is dependent upon whatever you put in for x, because whatever you put in for x will change this. So this is the independent variable. We put something in for this and it changes the dependent variable. So here's a chart. It tells us right now if we put in 3 for x and solve, you'll get 26. 2 for x gives you 18. 1 gives you 10, so on and so forth. So we see here this is a function because for every x value, there's only one matching y value. None of the x values repeat. They each have their own matching y value. So if we wanted to see what would the value of y be if x equaled a negative 3, well, you could do two things. If you have this chart, you could see that the pattern changes by 8 every time. And you could just figure it out that way. But let's go ahead and figure it out algebraically by putting in that negative 3 for 8. We would get 8 times negative 3 plus 2. Order of operations tells you you multiply these two first, which gives us negative 24 plus 2, which would give us a negative 22. So if you add a positive 8 to negative 14, you would get a negative, no, add a negative 8, you would get negative 22. Okay? So here we solved for that with our independent and dependent variables. Now, there's a couple more vocabulary words to look at in here. One is called the domain. And the domain is all the possible numbers that can be put in for the independent variable. So when we look at this, is there any number we can't use in here?
No.
Right. We could do any negative number, we could do a 0, we could do any positive number, we could do any decimal, we could do any fraction, and get a value for y. So the domain for our independent variable is called
negative infinity to infinity.
Or all real numbers.
Oh.
Or Simeon said, negative infinity to positive infinity. But yes, we call this all real numbers. You can put in any number for x and solve to get an answer for y. So the domain is what the numbers you can put in for your independent variable. So there's something major. Can you guys hear all the
You gonna get them.
Somebody's gonna get them.
Someone went outside.
All right, so next we have another vocab, the range. And I'm sure you've already guessed. The range is all the numbers that can be put in for the y, the dependent variable. Okay? Now here, is there anything we cannot put in for y?
No.
Right. So here, y can also be all real numbers. There's anything we can put in for y and solve to get x. So you're asking, well then why is this a thing? Isn't this going to be true for every equation?
No.
So, as Simeon is having fun answering, we are going to see some times where we cannot put anything in. For example, let's look at this. If you had y equals 3 over x. Let's look at x. This is our independent variable. So we are going to look for the domain. Now here we have a fraction. There is one number that we cannot put in for x because then it would make it no longer a fraction. Simeon, what's that answer?
Purple.
Or
0.
0. X cannot equal 0. You can't have 0 in a denominator. But we could put any other number. So the answer for the domain here is all real numbers except 0. Okay? All real numbers except 0 is the domain. Now, let's look at range. Let's look at doing range with a different equation. Let's look at y equals, I think we're going to do domain again on this one, 7 over x minus 1. Let's look at the domain again. Domain is what we can put in for x. Now we can put in 0 here. If we put in 0 here, it gives us negative 1, and we can do that. But because we can't have 0 in the denominator, if we put a 1 in there, that would make 0. So this is all real numbers except 1. We can't put a 1 in there because that would give us a 0 in the denominator. Okay, so you have to make sure you look at your equation and make sure if there's something in there that would make it, that it wouldn't work, a 0 in the denominator, for example, then you can't do that. You have to put the exception in there. All right, let's look at the next example they give us. The range, okay, is all possible numbers we can put in for the y value. So let's look at page 598 in the book. They give us this example, that paragraph at the top. Y equals 3 over x. So because we just talked about this, we know that the domain would be all real numbers except 0, because we couldn't put 0 in there. Well, let's look at the range for y, okay? Okay, this is explained in the paragraph at the top of page 598. But here for the range, in a fraction equals 0 if you have a 0 in the numerator. For example, if I were to have 0 thirds, that means you would have a pizza that had 3 slices and you have 0 left, so it equals 0. Or if I had 0.6, that would equal 0. So in order for a fraction to equal 0, there has to be a 0 in the numerator. Well, here, there's a 3 in the numerator, and that's not going to change. So this can't possibly ever equal 0 because there's already a 3 there. There's not a 0 there. So the range for this is all real numbers except 0. There's no way we're going to get this y to equal 0 when we solve, because we already know that we're going to end up with a 3, potentially. If x was 1, let's say x was 1, then it would equal 3. If x was 3, then it equal 1. But there's no way, there's nothing we can put in where the y is going to equal 0. Okay? What?
Do you understand?
Yes, I understand.
Okay.
I hope my students at home understand. So your range is looking at the dependent variable. Your domain is looking at the independent variable. So let's do some problems that are going to practice this. Let's look at letter D. Okay? Letter D in your book on page 598. We have to find the domain and the range. You have y equals 8 over x minus 3. First, let's look at the domain. The domain is what the x can equal. Well, that's in the denominator. Remember, the denominator cannot equal 0. So what would make the denominator 0 would be 3. So we know the domain cannot be 3. So we look at letters A and B, all real numbers except 3. So we know our answer has to be either A or B. Well, now let's look at why. As we just talked about, for a fraction to equal 0, there has to be a 0 in the numerator. Well, we know whatever we do, we're not going to get that because there's already an 8 in this numerator. So we know that y has to equal the range, all real numbers except for 0. So the answer to this one is letter B. Look at letter B and C, the examples. For letter B, all you do is take that value of x, plug it into that equation and solve. And then for letter C, you take the value of y, plug it in and solve. Those are just basic algebra equations. All right, let's look at the true, false, and we'll be done this lesson. A lot of people went outside. Number 1, in a function, the variable that's by itself on one side is the dependent variable, and the variable on the other side is independent. That is true. Number 1 is true. Number 2, the domain of a function is all the numbers you could possibly put in for the independent variable. Domain, all the numbers you could possibly put in for the independent variable. And that's true. The range, number 3, is all the real numbers that make a denominator equal 0. And of course that is false. The range is all the numbers you can put in for the dependent variable. All right, have a good week. See you later.